Sales and Marketing Advanced Mechanical Services Private Limited for their support and encouragement. I thank all the participants for joining us for this particular webinar. Now, I request our HOD, Dr. TV Sriram Reddy, to introduce and welcome the speaker for this webinar.
Good afternoon to everyone. It's my privilege to introduce today's speaker for the webinar, Mr. Swaroop Chand. Swaroop Chand has done BS in Physics and MBA from one of the reputed institute FMS Delhi in 1975. He has more than 25 years of rich experience in IT, CAD/CAM, consulting services for the mechanical and AEC industry. He is associated and worked as an evangelist with the computer industry to make best use of it. Thank you.
Good afternoon to everyone, and good afternoon to Dr. Reddy, Dr. Chandrasekhar, and I think Dr. Ashwath, and all the participants who have taken their time out to attend this. Can you hear me clearly?
Yes, sir. Yes, sir.
Okay, so can you make my slide me as a presenter, please?
Yes, sir. Yes, sir. You are the presenter, sir.
Is my slide showing?
No, sir.
No, sir.
Wait a minute. Wait. Can you see it now?
Now it's okay, sir. Visible, sir.
Okay. Perfect. So I'll make it a full screen. Okay. Good afternoon to everyone. I understand that there is from the invitation of Dr. Chandrasekhar, that there is a mix of participants. There are students in undergrad. There are some people who are a research scholar, and many of them are faculty. And I also understand he has sent the invitation to building association. So there may be some people from the industry. So my talk has to be little broad based, but I'll try to cover up as many applications in different areas of manufacturing uh, uh, in the different streams of engineering. Uh, we as a Droitech, as Dr. Reddy mentioned, work in emerging technologies, and that's what our core is in the area of engineering. Today, if we look at it, there are a lot of emerging technologies which are being talked about, whether it's robotic, artificial intelligence, IIoT, big data, 3D printing, blockchain. For the students and for research scholar, it's a boom period because any new technology means great employment opportunity and the advantage youth rather than advantage experience. It also gives a lot of entrepreneurship opportunities to people, and that's why so many incubation centers are being coming up in various engineering colleges as well as in tool rooms, so that you could take advantage of the existing facilities and be an entrepreneur yourself. But why so many technologies are being talked about? Why so many technologies are getting evolved? Because everything has to come from the need. If you look at it and you look at your own profile, there is a lot of discussion on personalization of the product to fit the specific need. And to meet that requirement, the cycle time for any product is reducing from years to a couple of months. We all know that in good old days, we had an ambassador car which would undergo a change maybe once in 5 years' time. Today, most of the companies, whether it's Maruti or Toyota, are talking of 5 models in a year. And on top of it, each model does go through the engineering change orders. These designs are not being done in one place. The prototypes are being done in different places. The manufacturing and sub-assemblies are being done in different places. And on top of it, we see that the usage is global. So truly the world is becoming flat, and that poses its own requirement and to be able to share the data. The product themselves are becoming very, very smart. They are no longer mechanical or hydraulic. They are a combination of electronic, software, apart from the mechanical, and they are networked. So since they are networked, we need to try all of them, and we need to bring all these technologies together and be able to be ready to make the changes as and when required. So we are discussing only one technology, which is 3D printing, and this is disruptive, transformative technology. The good thing is that it does not require any tools for manufacturing except the 3D printing machine. And therefore, the usage has become only usage for development, production, as well as for maintenance and supply of spare parts. So it's addressing all the 4 needs and thereby addressing a market which is close to $12 trillion market in the world. I have taken an example of a very simple product like a mixie. Now, if we open the mixie and we see some of the bought out items and some of the components which need to be manufactured by an individual manufacturer, typically it would require at least about 7 to 9 dies to be made before the product can be manufactured. And these parts are individual parts for a company because they give the look, feel, because the motor is same and the bearings are the same. What makes a difference in the different mixies are the plastic and the look and feel and some of the smart features which are added to each of the mix. Now, to make the 7 dies or 9 dies, it would take typically a developer or a entrepreneur at least about 6 months to get the dies developed. Now, he or she being an individual, the no injection molding guy will give the time to make 5 parts or 10 parts. So, what would you end up with? You would end up basically paying fairly high cost of getting these parts done, maybe 100 pieces in one go. All you know, the product may or may not work at that time. All you know that when you go to the market, the product may not be accepted by the market. So this one of the entrepreneurs came to me. He was a startup company, and typically for one model, he was told that it would cost him about 60 lakh in terms of capital investment, about 6 months. When he came to me, I said that why don't we try it with 3D printing? And we did with 3D printing, and instead of launching one model, he launched 5 different models with a total cost of about 14 lakh and in a period of about 4 weeks' time. So he could present in the exhibition and market a product which is wide ranging and therefore with minimal risk and with the ability to create a credibility in the market, he could go with about 5 different models, which is what enabled the 3D printing to increase the speed, improve the flexibility, and be also able to create innovation simultaneously. Now, that is a big, big thing for any entrepreneur. And if he can do it both in terms of capital cost and running cost, he does not have to store the parts and inventory. It's a boon for any new innovation to happen, which is what enables India to make in Bharat and also be able to prepare it for the global market. So it's a best time when innovation can actually happen and we can create innovators. It would help in product development to do the visualization, testing with the bought out parts, functional parts, and make it go to the market. When we come into the manufacturing, 3D printing is no longer addressing the prototyping. It's addressing the jigs and fixtures which are functional and can be used directly on the shop floor. Typically, a car manufacturer for one model will make close to about 700 to 800 jigs and fixtures, including the shadow boxes and CMM fixtures and things like that. They would need to make large number of gauges because they are dependent on suppliers to send the parts, and when the suppliers send the part, they need to check them with go-no-go gauges and other measurement tools. All of it could be done directly with 3D printing, and in many cases, metal fixtures have been replaced with plastic fixtures to make them lighter and also be more functional because they do not leave a scratch. It can be used for production because it is toolless manufacturing. So the small batch production can directly be handled by the 3D printing. Most important is that in our houses and in industry, the equipment lasts for 5 to 10 years time. At that time, we don't get the parts, and 3D printing can be an ideal way of replacing the parts or preparing the part as and when required. Are we okay, sir? Hello? Hello?
Hello, sir. Yes, sir.
Okay.
Yeah, yes, sir.
So this industry is growing very, very fast, and it's no longer being only in the automotive industry. Of course, motor vehicles do consume 14.8% of the 3D printers. Aerospace, industrial business machine companies are now taking the 3D printing services and equipment very, very fast. Consumer durable, as I just shared with you as an example, medical and dental. So today, 90% of the hearing aids and 80% of the aligners for the dental treatment are done by the 3D printing. And that's why people in academic institutions are now incorporating it as a part of the course fare so that the students can experience innovate, and subsequently get employment in different aspects of the 3D printing. In military and defense, it has taken a little slower pace because they have a very elaborate testing process. But today, some of the best of the parts and some of the most complex parts are now being made using the 3D printing. Architectural and fashion and design are some of the other people who have started taking the 3D printing. Is it only for presentation model? It's no longer. It's for fit and assembly testing. It's for patterns, for prototype tooling, for pattern, for metal casting, tooling components, functional parts, and different applications. As you can see, I have basically illustrated it with different examples. In tool and die making for injection molding, the conformal cooling has been used extensively to enable the efficiency in injection molding process. And that's why customers across the world are now practically started using the 3D printing in their day-to-day applications, in their design, in their shop floor, and definitely in supply chain management. Let's look at the various technologies which are available, because there are certain students which are undergrad students, and they may like to understand the different technologies. Many of you may be familiar with it. Reasonably any 3D printing process involves, if you look at the stage one, if that's a product that you want to create, except the T, right? We would 3D model and then slice it into layers. And these layers can be as thin as 1 micron. Depending on how accurate do we want and how good finish do we want, we would make that many layers. Of course, with the increase in layers, the speed of printing goes down. And then on the 3D printer, we print one layer, then the bed goes down or the bed goes up, and the second layer gets printed. Because of the adhesive property and because of the temperature at which the material liquefies, we just keep it just above the liquefaction temperature, and the material comes in the liquid form and then gets stuck onto the previous layer. Therefore, by layer, if you look at the stage 4, you are able to create the product which can be used directly. So, in brief, the product to do any 3D printing would involve making a CAD model, doing the selection of the material which we want to print, and therefore corresponding type of printer and technology which we want to use. And based on that, using a 3D printer, you print layer by layer. So you don't need any tool over and above this. So you don't need a CNC machine, you don't need a wire EDM machine, you don't need a lathe machine, you don't need other machines, except that for finishing, you may need to do the grinding and finishing at later point of time. So one of the simplest technology and one of the most accepted technology, and this is called FFM or FDM, fused deposition modeling. The material comes in the form of a wire, and this wire goes through the pinch rollers to push it down, and then there is an extruder where the heating takes place and the material gets melted. When the material gets melted, the extruder is mounted on XY Cartesian coordinate, which is moved in the X and Y direction based on the geometry of that particular layer. So if the geometry defines that it has to move in a circular fashion with a diameter of 8 mm, it would move with the 8 mm dia and deposit the material to make it a circle. Then subsequently it can be 8, 8.1, 8.2, depending on how much thickness we want of that particular layer or that particular circle. So because in one rotation it may have 0.4 mm or 0.2 mm thickness. So if we want 0.8 mm, we may rotate it at 4 times and may also create increase radius over a period of each rotation. Thereby, you make a 3D printed part, and that's typically the way a 3D printer would look in the simplest form. There is another technology called SLA printing. In the SLA printing, the technology remains the same. The difference is the way we cure the material or the way we melt the material. In this case, we fill the material in the form of a tank, and it's in the form of resin, which is optically treatable. When I say optically treatable, means it gets solidified at that particular geometry wherever the light falls. So you are, instead of moving the extruder, you use the laser source which is fixed, and you move the mirror, and this mirror is moved in the XY direction to give the geometry, and based on the light falling on the resin, it prints out the geometry, or it hardens the resin at those locations, and the remaining resin is not hardened. Then the bed again goes down, or it goes up depending on the type of printer which we are using, and then the printing happens layer by layer, and the curing also happens. So there are different stages through which the printing happens, and as you can see at the stage 4, the part is getting layered by layer manufactured, and the material is kept in the tank, or it's also called the vat. Okay, and if you look at the part number 2, it takes the part up or down to make the next layer. So if it's taking it down, we print it straightway. If it's taking it up, we print it invert. The part is inverted. Now the 3D cell layer, so that you can work on the whole collagen and be able to test it out. In the case of metal powders, we need to be slightly different. And in the case of metal powder, you spread the powder, again, one layer, depending on what is the thickness of the layer, and then using the same technology like laser, in this case, the laser, therefore, it sticks to the next layer and next layer and next layer, and thereby the part gets produced. There is another technology called, this is called the powder bed fusion. There is another technology called DD technology. In the case of DD technology, you don't spread the powder. You keep the powder in a hopper, and the powder comes in a calibrated manner, and the laser also comes. Maybe the next screen will show that better. Yeah, here. So the powder is a gray one, and the red one is a laser beam. So the powder comes in, and that gets melted by the laser, and then you deposit it like in FDM process, the particular part, and the whole extruder or the whole head moves in the XY direction depending on the Cartesian coordinates which have been given. So in the case of, there are 2 more technologies which have come in. One is called metal injection molding. In the case of metal injection molding, the metal powder is enveloped in a plastic, and this plastic is laid like an FDM system. And when it has been laid and the sticking has been done, then you do the sintering. And on sintering, what happens is that the plastic gets evaporated at about 200-300 degrees centigrade, and the metal powder gets solidified. And this powder, when it is heated up to 1300 degrees in a muffle furnace, which is gradual heating, you are able to get the parts which are solid parts. And these parts are very, very good. The metal injection molding is a very old technology, but it has been adapted in 3D printing process very recently, because it gives the convenience of being able to print a metal part on the desktop. And to give the support, you use the ceramic layer. So there is a second wire, which is, if you can see, there are 2 spools on this printer. So the second wire is a ceramic wire, which get deposited so that the support can be created for the overhanging parts. In the plastic, there is one more technology which is coming. Sorry, I think there is something. Can you see it, sir? There is a new technology which is called multi-jet fusion. This has come from a company called Hewlett Packard. This is a very unique technology because here what they do, they spread the powder, which could be a nylon powder or could be even a metal powder. Now they have launched a metal machine as well. Now in this, what happens is that the powder gets spread in thickness of 80 micron, and instead of heating it up with laser or treating it with just light, they have a 16,000 small infrared lamps. So first they create the geometry like an inkjet printer. So this ink is thermally sensitive ink. So once the geometry is done with the ink, then fusion happens because the infrared light creates enough heat, and the ink is a thermally sensitive ink. So since it's thermally sensitive ink, only at the places where the ink has been spread, the powder get melted and it get fused with the previous layer. The advantage of this technology is that it's a clean technology, no oxidation happens, and like inkjet printers, the precision which you can define is very, very high. And three, since you can put multiple ink nozzles like in an inkjet printer, you are able to print full line in one go, and thereby you print in one run of the head, the full page, and therefore the speed is very good. And because the ink is thermally sensitive and it creates a melt pool, it's the only printer in which you are able to get the homogeneous homogeneity in the part. So the part strength is the same in X, Y, and Z. In all other printers so far, the Z axis used to be about 60 to 70% stronger than the X and Y. But in the case of MJF technology, you are able to get the part homogeneous in all directions. It's able to have the same force. The other technology which has come up is the composite. So you are no longer dealing with only the plastic or the metal. You are able to deal with carbon composites, fiberglass composites, Kevlar composite. So a company called Markforged prints the part where if you see on the top right corner, you are able to lay the continuous fiber like a reinforcement you do in concrete wall. So since you are able to create the concrete wall reinforcement, you are able to get the flexibility as well as the strength, which is very, very high. And if you see the parts on the left side, okay. So if you see, I'm still not able to annotate. Dr. Saab asked for the annotation and to, okay. Can you see this part? This part is very, very complex. Now it cannot be done by injection molding. With the help of 3D printing, you are able to create it as a single part. And you see a lot of gaps in this, like this. You are able to make the part very light. You are able to make the parts very strong. And you are able to create fairly complex geometry with no tools. So as you can see, it's a transformative technology. It's a disruptive technology, and it has the advantage for the youth. X is basically non-experience. So X is experience, inverted X is those who are younger are the one who can adopt the technology much better. Like any other disruptive technology, like mobile phone, how many jobs did it create in terms of writing software, in terms of writing apps, in terms of communication, in terms of security, in terms of hardware maintenance? Like in the same way, when the Ford introduced the automated engine driven by the petrol, you saw how many employment did it create over a period of time. In the same way, any of these disruptive technologies or breakthrough technologies will impact new employment opportunities where the youth will have the advantage. In brief, 3D printing is reducing the cycle time to design, reducing the manufacturing time, reducing the repair time, and of course, you are able to try different alternatives to be able to improve the aesthetics of the product and make customized products to meet the needs, specific need. So there was a guy from he used to make special purpose industrial machines. Now, when he used to make special purpose industrial machines, typically when he used to give the parts for manufacturing, no one will give one part. They will give 5 parts, 10 parts, 20 parts. So when I went to his factory in Pune, I saw 6,000 parts stacked in his on his shop floor. And he was implementing SAP and everything to manage those parts. When I discussed with him, he could not even think of a new design, even if he knew what the limitations of the older design, because he had to use his inventory. When I went to him and I said that why not you get the parts done for a specific machine using the 3D printing. There were about 680 parts, of which 300 parts were made in plastic, which would have required injection molding. Another 60 parts we converted from metal to plastic because it was much easier, it reduced the weight, and it was possible to manufacture it, and it was not affecting the life of the machine. Today, he sends in the beginning of the month that I want to produce machine number 3, and these are the 7 parts which I have changed. We practically make a box and send it to him on the 4th day, and therefore the whole question of inventory, whole question of vendor management, whole question of supply chain, all gone. And he is able to have the flexibility to make the changes in his special purpose machine as per the client requirement and based on his study of how to make it in the best possible way. 3D printing is a game changer, and there are different type of printers: chocolate printers, ceramic printers, cement printers, electronic circuit printers, metal printers, plastic printers, carbon fiber printers, and even the Play-Doh printers. It's being used by everyone. It's being used by doctors, designers, sculptors, dentists, civil engineers, artists, chefs, toy maker, architects, fashion designers, interior designers, and of course, industrial applications of aircraft manufacturing or automotive manufacturing and consumer durable. And today, you would have also read many of the people that they have started making the bridges and custom houses using the 3D printing capability. Just to share with you some of the pictures and examples, and I have some more examples given in detail at later point of time. Depending on the availability of time, we will discuss them. It's being used for making the sockets very effectively. It's being used for surgical planning. It's being used for prosthesis. It's being used for making the cranium. When the skull breaks, you need to do the replacement, and that is where it is being used, both in titanium and in a material called hydroxyapatite. So if you see this leg, could we have actually manufactured it with a CNC machine? There was no possibility. We would have left a thick plate, which would have been very heavy, very inconvenient. We would not have been able to provide the cushion to the leg, We would have tried with a spring, but if you see at the bottom, you have if you see this area, this itself acts as a cushion and it gives the convenience to the patient. You could make and carry a customized chocolate cakes for your friends and with the names and faces written on them. People internationally have started using it for making the cakes, and also internationally there is also a fashion that the small model of the boy and the girl is also made when they get married. Those can be definitely done with the help of 3D printing. A lot of glass manufacturers, the specs manufacturers, are now using the 3D printing. And of course, you could make a customized gift for your friends. Can the sculptors use it? Today, I saw, if you see these two sculptures, and I'll show you some more. In Denmark, they are being used as the garden furniture to decorate, and that's what we go to see. So if you look at this is actual photograph of a garden from where this has been picked up, where it is being used as a garden furniture. It's a beautiful picture where even the light has been provided inside, which really looks very nice. And the whole thing got printed by the 3D printing process. You could make a face and you could also make the doll, which is very personalized. So these are a few of the examples of architect and homemaker and doctors and automotive companies who have started using it. If I share with you one more example, look at this structure. And look at the structure above it. This was a solid structure. This was a much lighter structure. It gave much higher strength, and this is the one which is used at the bottom of the seat in the aircraft. It reduced the weight by about 26 grams. By reducing the weight by 26 grams, you are able to achieve that much lighter weight because there are typically 300 seats, and in 300 seats, there are 600 brackets, which means you're able to shave off close to about 60 kilograms weight. One more person can be carried. Just to share another example, this NIFT, National Institute of Fashion Technology, started using the 3D printing, and a year and a half back, they arranged a fashion show which is completely based on the clothes which were done by 3D printing and the accessories which were done by 3D printing. So this gives you some good examples of 3D printing in the common world which we go through every day. So what are the technologies and what are the various 3D printers which exist today? There is a FDM printer, which I'll touch upon that. This is one of the ceramic printers. So you could make the ceramic, and of course you could make the automotive parts in large quantities. So typically the 3D printing is being used for functional prototyping, tooling, as well as for producing the final parts. Sir, just to share with you and for some of the people who are attending it, during this pandemic, when they had to make the face shield and they had to make the sorry, when they had to make the face shield as well as they had to make the ventilators in the pandemic period, the total number of parts which got produced by 3D printing in India is close to 2 million parts for ventilators. Okay? So they are airtight, they're watertight, and they do not react with chemical nylon as a material, and they were accurate to the level where you had the accuracy of 40 to 50 micron. You could use it for functional prototyping to mix it up with bought out items. You could use it for tools. You could use it for final part, and it could be used in military and defense. It could be used in aerospace. It could be used in transportation, which could means all the vehicles. It can be used in healthcare. It could be used in consumer goods and electronics. Name it, and you would find a use or a customer in that area. What are the challenges? If you look at the challenges, the questions which come up in different people's mind: can I print polymer? Can I print different type of polymers? Can I print metal? Can I print ceramic? And what is the type of post-processing I need to do? What is the software which is required? And will it perform? Will it have, and I'll share with you the different technologies for different areas in which Adroitic has been working. So if we look at one big area where the employment will be very high from international market is design optimization. If you look at the part in the yellow on the top and part at the bottom, they both work the same. The advantage is it's lighter weight, and more important, when we provide a thin sheet in between, this sheet, if you look at it, with the load, this will crack because this is not as thick and as strong as other parts of the which have been provided. But if you look at this one, the structure itself is self-supporting, and not only self-supporting, but it also gives the flexibility to the part without any cracks developing. So companies like ANSYS, Nastran have now started developing the optimization package by which Altair have started doing the development of analysis package by which they are able to analyze a part and be able to certify that with the reduction in the material and with the optimization of the part, you are able to achieve the same performance or even better performance. The great advantage is for 3D printing being toolless, you never try it either in injection molding or by CNC machining because it would mean extra process and means extra cost. But in the case of 3D printing, geometry is an advantage. And if geometry is complex, more the complex the geometry is, better the justification for 3D printing comes in. Another example of how the weight could be reduced and the performance could be improved. So companies like Siemens, PTC, all are working to ensure that now they are able to incorporate within their 3D modeling capability, the additive manufacturing capability. So you can well imagine, and students can well imagine, that if companies like PTC, Dassault, Siemens, from the software 3D modeling point of view, are working in this area, companies like ANSYS, Altair, or Nastran are working in design optimization, or companies like BAS are work, and number of other material companies are working to develop new materials, and thousands of companies like HP or DMG Mori have now started to making 3D printing. What is a big opportunity which exists? Because if all of them are seeing a big opportunity, I'm sure you can see that this is a big opportunity for you in terms of employment. So lots of opportunity around another disruptive technology in each area, and to address the complete design concept to maintenance is what you can address, and it's an advantage youth. No experience exists as of right now, and no experience is expected. So new opportunities which will rule the world is what is a key. The only thing which ought to be able to get exposed to any of these technologies, which are going to be used for prototype, tools, jigs, fixtures, making, vacuum casting, software making, functional parts. Sorry, sir? Okay. Let me share with you some of the platforms, which is the 3D printer. We have time. Okay. So we are looking at a printer which is a carbon composite printer and also the metal printer. It gives the strength, the carbon composite material gives the strength which is higher than the aluminium strength. And the metal parts are giving you the quality of parts which are stronger than the casted parts, not as good as the forged parts, but close to the forged parts. The other printer which we have is a HP MJF printer, which is a multi-jet printer. And in this, you can do the production. So you have a separate unit. This one called pre and post processing unit. So we don't have to take the 3D printer time for doing the filling of the powder or taking out the powder or cooling the nylon after the print has been done. So that this is acting as a printer. And the other one is acting as a pre-processing and post-processing system. The speed and the production rate are very high, so it's typically used for production purposes. But they also introduced a machine which is called HP 500 series, and the HP 500 series is a machine which is full color. That means you can generate true color printouts as live as any other painted job would be. In fact, better because you can go very highly accurate. So you could print parts like this, which could be used for demonstrating how the FEA model would behave like, or it could be used for surgical planning, or it could be used to number and also fix the barcoding along with the printout to the jigs and fixtures so they do not get lost. So they can be used for consumer goods as well as for labels. These are some of the examples of a color printing. And since they use a technology called ink, and this ink can be treated in any manner, so it could be thermally sensitive, or it could be electrically sensitive, or it could be magnetically sensitive. And since it can be made in any of these properties over a period of time, right now they have not launched it, but they can incorporate the features of electrical conductivity while the printing is going on. So thereby you could actually print a conductive layer in between. There is a third printer which we have, and this is the printer which we have designed ourselves and are manufacturing it. Here we looked at the simple technology that you are moving on the Cartesian coordinate all the different type of extruders. So what if we can put 5-10 extruders simultaneously and can print with any of those extruders at any time, defining the features. So in this machine, we have a bed size of close to about 600 by 400 by 250, and you could mount simultaneously multiple extruders, and these extruders could be of different types. So if I just share with you, there can be extruders which can print plastic material which is about 300 degree. It melts at about 300 degree. Also materials which can melt at about 450 degree. So you could directly print in PEEK and ULTEM, or you could print in flexible material. Then you have large number of extruders where you can print in gel form. So directly you could take a gel and could print it out, or you could print in semi-viscous material like clay and rubber material, or you could also replace it, and this could be warm or cold depending on what is the requirement, or you could also have a laser as an extruder. Thereby you could do the cutting, you could do the routing, you could also do the measurement as an inspection. So you could make the same machine as an inspecting machine, you could make the same machine as a laser cutting machine, you could make the same machine as a routing machine. We recently also developed a CNC tool on it, so you could directly work on a 3-axis or a 5-axis CNC machine. Right now we have not achieved 5-axis, but we have achieved about 4-axis. And then we also developed the extruder, which can be fed continuously with the wasted plastic material. So we developed a process by which we could break the plastic bottle like PET bottles, crush them, feed it, and that material comes based on the controller of the printer and could print it out directly. So it can be very easily called as waste to effective, useful products. So here we have a very good control because we can develop different products to meet the different researchers' need, and we can also use it for different applications. So recently, BHEL came and wanted to work with a complete mold in which they would do the casting, and using the mold material, they produce the mold directly using the 3D printed and then did the casting, which was not possible for them because they were working on an impeller, and impeller on a hydro turbine is a very big part. We also have a printer called Delta Wasp, and in this 3D printer, we can print plastic as well as clay and ceramic. So you have all the facilities which are there. Why I'm sharing these examples is not to sell you the printers, but to share with you that what are the different technologies which are available and you can use them. This is a printer which is a very large printer. So here you can go up to 6 meters in length and you could print as big part as a full vehicle body. So I can print a full car body as a single piece using a printer like this. And it comes in different forms. In this printer, we directly use a pellet. We don't use the wire only. So we can use a wire, but we can also feed the pellet directly like in an injection molding and can print in large quantities. So you can go as much as about 4 to 6 kilograms per hour. The metal printers are a different story. We can print in different type of metals to be able to, this is called the metal fusion technology, which I shared with you, is a technology where the metal powder is enveloped in a plastic and then the printing is done similar to the FDM printing. And based on that, then you do the sintering. The interesting thing in this, you can print, apart from the material like stainless steel, tool steel, Inconel, you can print in copper. So, and this is a pure copper. So you can get 99.9% purity of the copper which can be printed and can be used directly. So if you have a sandwich model where you have a plastic piece and also copper for conductivity, you can do that. Sorry, sir? Okay. So this is the type of a part, and then you can do the machining on the part. The other technology which I shared with you is a DD technology. This technology, as you can see very clearly, can be used for printing large metal parts. And you could use it for inducers, CF pump impellers, open impellers, hydraulic manifolds. These are terms which you would have seen, but these are functional parts and you can work with them. The most interesting thing with the DD technology is that you can use it an existing part, and on top of it, like welding, you can deposit the new material. So in this case, there is a scanner which is built in. It looks at irregular shapes which got created due to the wear and tear or maybe due to the breakage, and it immediately identifies those areas, and you are able to deposit the same material which you had before. And this fusion is perfect. When you take an X-ray, you are able to see that the fusion has happened between the old part and the new part, unlike the welding, where the welding lines get seen. And this can be used for repair. So one of the cases in Korea is that one of the engine workshop could use it directly to repair the front portion, which is called the shroud, and which get hit by the bird using the 3D printing. Typically, dies do wear off at certain places, and we normally make dies of either the aluminium or stainless steel. But in certain areas, the die wear off because the walls are very thin and with repeated impact, they break. So we cannot afford to make them in titanium because then the cost would be very high. But using a technology like DED, you are able to do selective titanium deposit on the areas where the wear and tear is very high and therefore increase the life of the die and therefore the production as well. So I am just now sharing few of the examples how different applications can be done, and therefore I'll run through it relatively faster so you can get a near net shape part and then can do the CNC operation or the finishing operation to get the finish of the parts. Like in this specific case, the complete casing of a bombardier was done, of the vent system was done completely using the 3D printing. Or you would have seen a lot of casings which come in and they do breakdown. Can I make the 3D printed part and do the maintenance? Braille is very critical, and especially in some of the parts where you need to inscribe the Braille, you could directly do with the 3D printing the name of the part itself, and you could also print the Braille on the marking on the component. Typical application of casting, because in India there is a lot of casting application which is done. The pattern is made out of the wood, but now with the help of 3D printing, you are able to make the pattern in plastic, which is as good as the wood, in fact better because its life is very long, and you don't need to store the pattern because you could store them as digital pattern, and therefore you could make the parts more accurately and much more easily. I'm just sharing with you a few examples of the pattern and how the casting could be done for the very, very complex shapes. The other application is typically in sheet metal, you need to make the small tools, which are called the forming tools, which strike the sheet and can give the bend as per your requirement. These can be directly done using a carbon fiber printer, and which lasts for a long time, and they are much lighter, yet they are equally strong to be able to do the sheet metal forming dies. The other very interesting application which started happening now is that connectors used to be made as standard connectors which are taken. Now they have started making because now the products are a lot more smart, they have started making the connectors which are smart and which are comprehensive directly from 3D printing. And since we have the color, we can do the color coding of the connectors to be able to do the subsequent maintenance at later time. So you can see some of the complex connectors which were done using the 3D printing feature. Or you could write on top of the connector or the jig directly the barcode, the QR code, as well as the information of the jig. You could do the labeling, you could do the routing fixtures, you could do the testing fixtures, you could make customized connector holders. So typically in an electric train, if you look at it, this is how the wire harnessing would be there. Now, can I do the complete thing which is color coded instead of just putting labels which go away after a certain period of time? Recently, we also did one very interesting example of using the 3D printing for making the complete 3D terrain model, which was accurate and could be measured. This could be used for war planning. This could be used for city planning. And recently, one of the guys came and said, can I use it for flood planning or water drop planning? So he created a small fountain on top of it, which is with calibrated rainfall. And based on the scale factor which he had chosen, he could also do the complete how the water, if this is the level of rain, which are the parts of the city which will get affected. And the picture was taken from the drone, and from the drone, it got converted into a full terrain model. So I shared with you some of the examples of 3D printing. Now I'm going into more details of how even a metal part, which was in 3D printing, and this is one of the big areas, typically this would have been the assembly. Can you see this assembly? And this many parts were used to make this assembly. This is basically for in an inkjet printer, how the ink moves and during the print, and how the slurry is used to clean nozzles. These many parts were there. Using a 3D printing, it was converted into a single part, low maintenance, and the cost came down significantly. Can we make a duct? So a company like Shell in India is using it for making the ducts, which are very complex and could take a 3 dimension. So instead of making different parts and providing the seals, seal is a one area which gives the maximum problem during the operation, and it requires regular maintenance. Using 3D printing, now they can print the ducts and the areas where there is a complexity, not the straight pipes. Straight pipe can be directly used by the conventional method and could convert it into a 3D printed part, which reduce the cost, it reduce the part volume, it reduce the time to manufacture the part. Since some of you are welding people, I also put few of the fixtures which are used for welding example. And if I look at these 2 pipes on the right side, they needed to be welded at a particular angle. If we had to hold them, it would have been a challenge. But now with 3D printed jig, which could be customized to a specific need, you could practically hold those 2 pipes and could directly print it out. Assembly is another very big area. In assembly, like company like John Deere in India, I'm taking these examples from India and some from abroad. So you could use it as an assembly fixture to fix the parts, 2 parts very quickly and with no alignment problem and no screws or getting tightened at an angle. During the welding process of a large part, you need to hold the part and also have to remove the part. To be able to do that, you could make a welding fixture which could be used, and then the welding could be done. Many time on a shop floor we use soft jaws, but if you look at the right side example, this example, typically what would we do? We would take 2 blocks, to do the grinding. We would use this block, which are straight blocks, and put a lot of pressure so that the gear does not move, and then we would do the grinding. Now that would mean force, and that would mean high wear and tear, and there would be always a slippage which would happen. But using a 3D printing, I could make the block. If you see this block, which has the negative of the gear tooth, and since it has the negative of the gear tooth, you are able to fix the gear much more easily with practically no pressure, and you could replace a steel block with a simple carbon fiber or a carbon composite block and could do the printing, could do the finishing. So there are plenty of examples of the soft jaws which are used for CNC operation, which are used for wire EDM operation, which are used for boring examples. A company like Sla use it for assembly process. So all these black parts which you see are being used for as assembly fixtures for doing the reduction in the cycle time during the assembly process. Company like G use the 3D printing not for making this part. This part, they make it with a metal printer, right? But when they had to do the measurement, they had to put it on a CMM machine. Now, when they put it on a CMM machine, typical setup time would be at least about 10 minutes. And the measurement time would be maybe a minute. And typically, you would put the part using the V block. Now, using the 3D printing, they could make the part, which is a fixture for holding the part. And since it was in carbon composite or a material, it did not leave the scratch on this fuel engine, fuel injection system. Similarly, another example, or laser marking, all are good examples. Or an organization like Caterpillar, when they had to do the measurement, this white portion is a block which they made to fix up the part and do the measurement very quickly, saving a lot of money. You have all used the CNC machine. In CNC machine, we need the bar pullers, and they are customized. And all the CNC lathe or bar pullers could directly be made using the 3D printing to do the customized work. Same way, you could use it for die holding. You could use it on a shop floor for the fixtures to be made to hold the part. In this specific example, there was one particular fixture which was to lift this car which had broken. Using a carbon composite, they made the fixture, and in this factory, the production speed was close to about 10 seconds per car. It now carries a load of 2 tons, and it's working regularly and working comfortably. Another example of a CNC, instead of making a soft jaw which would hold it with pressure, you could give it a shape. I also put some of the examples in the medical area. You would have all have some people or some friends having the back pain. Now, typically you use a belt. Now, using a 3D printing, you can make a brace at the back, which would be completely holding the back and then can be used by the person more comfortably. Or the foot leg for prosthesis. So typically the process would have been the casting process, but now using the 3D printing, you are able to scan the area on which the casting on which the prosthesis need to sit, and you could print a lighter part which is more comfortable. See this portion? Typically, when you have an ankle injury, you have to hold the ankle. And today, the only method was to do the plastering. Now, with the 3D printing, you are able to create a leg which holds the ankle very effectively and yet does not cover it up fully, and therefore more convenient. So these are some of the examples in the area of medical which are existing and which are being used. So today the braces which used to be put on the teeth to correct the angle has been replaced with aligners. And the scan is taken like you see it in the black at the bottom. This one. So from the scan, the model is created, and on this, the thermoforming is done with a plastic material like this. And with this material, then the alignment is done so the person does not get those bristles in the mouth and is able to remove it at the night and put it back in the daytime. Foot correction is one big area in which the 3D printing and customization is very critical. So I just shared with you examples related to some of the examples related to medical. In the same way, when we are making an electric vehicle, the tubing and the cooling arrangements are very critical, especially the battery cooling is very critical. Can I make all those parts using the 3D printing? I just am showing you some of those examples. Electric vehicle, drone parts. So today, there are 7 drone companies which are getting the parts done only on 3D printing based on the requirement in India. Manifolds are another very big area where 3D printing has been used. So I hope this gives you a wide scope of examples in oil, gas, defense, fixtures, tooling, where the 3D printing has been used, and will give you an idea of how new innovations can be done, and also give you an idea of where the employment and entrepreneurship both can be enhanced using the by taking good skill learning on the 3D printing as a effective area. This is what my detail or brief presentation is. It can go on for a couple of more hours, but I thought that this would give you the exposure of. Thank you very much. If you have any questions, and I would still again invite you to my factory in Bangalore and in Noida to be able to see what are the features which are there. Sir?
Hello.
Yes, sir.
Sir, thank you very much, sir. The session was very interesting and informative. Now I will leave the session for question and answer, sir. Dear participants, if you have any queries, you need any clarifications, please ask Swarup, sir.
Good afternoon, sir.
Yes, sir.
Sir, my name is Vijay Kumar. I'm speaking from Mangalore.
Yes, sir.
Sir, my question is there any automobile part recently which has been refurbished by 3D printing, sir?
Sir, the parts are not refurbished. Parts are either made in automotive industry, or they are either they are manufactured by 3D printing, or they are the tools which are needed for those parts to be manufactured. The tools are refurbished. So there are a lot of parts. So in fact, we did one work with a company in Coimbatore where they were doing the spinning and in a CNC machine, and they had to jig for holding, which was heavy. As a result, the production speed was about 4 seconds. By redesigning the jig and by making it lighter, they were able to increase the productivity to 3.5 seconds on the same CNC machine.
Okay, sir. Thank you, sir. Thank you, sir. Thank you, sir.
Yes, sir. I have a question, sir.
Yes, sir.
Sir, what I wanted to ask is there any speed difference between 3D printing and CNC machine, or is it just the same? Or does it depend on the component that we are manufacturing?
In fact, CNC machine for a large volume production will always be faster as of right now. It is not used, 3D printing is uneconomical when the volume goes beyond 500 to 1000 numbers. Because as of right now, the material, the machine, and the overall cost which comes in is much higher. But when there is a need of tooling and this thing, the time get reduced and the cost of development of those tools is so high that up to about 1000 pieces to 2000 pieces, if the geometry is very complex, then even up to 5000 pieces, it's more economical to do it with the 3D printing. There are two more areas where 3D printing become very useful and people are switching it over, though the cost comes out to be higher and the speed also comes slower, is when they have to integrate parts. So there was, you would have seen Eureka Foods RO system. Typically in an RO system, there are three areas through which the water passes before it gets filtered. Now, on the top, there is a pipe which carries the water from one cylinder to another cylinder. They were using 11 components in that system, and they were all connected with the seals. So they were putting rubber seal in between, and that used to take away a lot of maintenance time. Using a 3D printing, we were able to convert it into a single component and thereby improve the reliability. In the aerospace industry, where the number of parts are not so high and the complexity is very critical, is very high, So there was a company which was in the specifically I'll mention it. It's Bell Helicopter. They had to do the drilling for riveting application, which where the drill had to go at 90 degree to the part. Now aircraft is always very complex shape. So they were making the jig, which would be exactly fitting the part, and then the drill could move at 90 degree because the jig will support it at 90 degree only. They came to us, we made it in nylon, and we fixed it with the now the jig. Typically, drill will move at about 10,000 revolutions. So what we did, we fixed it up. We made the jig of the shape of the part where the drilling had to be done, and then inside it we inserted a bolt which is made of titanium. Now with that, the life of the jig became very high, and the jig became lighter from 3 kilo to 1 kilo. So it became very convenient for the person. So giving you a long answer to your short question, the thing is that many times you have to look at why you need a 3D printing before looking at just the cost as a factor.
Any other questions? Sir, I have one question in the chat box.
Yes, sir.
Person name Dr. Manavalan from Tiruchirappalli. He just want to know the significance of multi-jet fusion processor.
Sir, fusion process is very accurate, and more than accurate, it is the only technology which has been able to give us an isotropic properties. So the X, Y, and Z, you have the same properties. In this, we don't use laser, so the maintenance cost is also lower. And you are since the material, the powder is spread, and like inkjet printing on a typical inkjet printer, you spray the ink on the whole page. And since you spray the ink on the whole page, the speed with which you can print it out is also much, much faster. And you don't need any of the environmental things, like you don't have to have argon gas or helium gas or anything of that type. You are able to print it out in a room which is 12 by 12. I can send, if you send me the mail, I can send you the detailed presentation on the MJF itself and the way the technology is working.
Okay, sir. And a few participants are asking for PPT, sir, presentation.
I have already sent this PPT to Shashi, so you will get this PPT.
Okay, sir. Thank you, sir. Any other questions from participants? Okay, right, sir.
Thank you.
On behalf of Bangalore Institute of Technology, I thank Swarup Chand sir for his time and encouragement, and he accepted our invitation for presenting his expertise and experience in the additive manufacturing. Thank you very much, sir.
Thank you.
And also for your patience listening. And he said